Hello, glad to see you all here. So today we are talking about space robotics, engineering of the future, and we'll have two presentations. First talk will be done by Dr. Lutz Richter. He will talk about lunar economy, and then Dmytro Khmara will give a talk about applying commercial of the shelf components for solutions with satellites. So before we start, I want to say that if you have any questions to our presenters, you can ask those questions in chat and in Q&A here. So you have a bar in the bottom part of your screen. So there is a Q&A and there is chat. So you can click on this chat. Then you have to select when there is two field called two. You have to select like everyone, or if you want to ask some personal question, you can do it, and you can type something here. So let's give it a try to make sure that all your questions will be addressed to the lecturers. Let's type here from what country you are, and maybe what city are you from. Let's try this. Okay, so I hope, yeah, I hope you can hear me, guys. So so I see that you're typing, so that someone is typing in Q&A. So great. So we have people from Ukraine, Kyiv. Somebody saying that Grzegorz is saying that the chat is disabled, but you can, Grzegorz, I can see your message here, so you can type all your questions here, and you can type also your country and city here. Ivan mentioned same for you. So if your chat is disabled, you can type your questions in Q&A. So it's good that we have two options. So we have people from Kyiv, people from Lviv, from Rzeszów, great, from Warsaw. Oh, we have somebody from Canada, great. So Adam from Gdańsk, yeah, I don't know why chat is disabled, but it's great that we have a second channel of communication. Fine, good. So let's.
Yeah, Lubomir, let me probably say something. Yeah, so if your chat is disabled right now, you can please text something in Q&A, and we will try to figure it out. Yeah, technical issues happen, but we will try to figure that out. Thanks God we have Q&A. Yeah, we'll try to figure it out. Thanks.
Okay, so we have people from Wrocław, from Rivne, Ukraine, again from Wrocław, from Poznań, from Lviv, Kyiv, okay, and good. Good. So we have a broad audience from different continents. So from, yeah, that's really great. I think that let's spend a second and help our speakers to understand the audience. So we have a little very quick poll here to understand what is your experience with space robotics. So I'm going to start the poll now. There will be only one question there, so very quick, but so I'm doing it now. You can see this poll on your screen. Please select the answer of your choice. what is your experience with space robotics? Great, thank you for your answers. Now we have 40% of answers. Yeah, so okay. 70. That's great. Let's wait a couple of seconds to let everyone vote. Great. So I'm about to end the poll. So we have like last few seconds to vote, and then we can see the results. So okay, I'm ending it now, and let me share the results with you. So 59 people voted, so we have 7% of people who do have experience with space, and we have almost half of our audience who are familiar with robotics, but they have expertise with space, and another half, or almost half of the audience, who do not have much experience with robotics but are curious with space robotics. So it's great. I think that this is the perfect audience for this event, and I hope that you will get the great outcome from what you're about to hear from now on. Okay, so when I was thinking about this time when we in which we are living, and I think this is the time of the great exploration and of the great advancement of humanity. Just think of it. In January, we had a James Webb locked in its position. And then in February, we had an anniversary of the Perseverance drone on Mars. In April, we had two events with Action 1 and SpaceX Crew 4, who had the missions to International Space Station. We also had a Boeing company who docked to International Space Station. In summer, SoftServe launched the space direction as a part of robotics team. So together with our drones, mobile platforms, robotic arms, together with what we are doing in simulation and modeling. Now we are entering also space, and I hope that there will be lots of different interesting projects that we will work in. But the year is not over. We are still waiting for the Artemis mission to bring humans to Moon. We are still waiting for the launch of NASA and SpaceX Crew 5, and yet we also in December there should be a NASA mission for exploration and on the Moon and resource and ice mining. So yeah, it's really the year of great achievements in space, and I think that you can answer what are we especially looking on Moon, and why are we going there? Why this is important for us? So if you can reveal that would be great. So passing the mic to you.
Yeah, I mean space in general, let's say even satellites around the Earth is becoming, let's say, more common or more affordable, let's say, because there are smaller spacecraft, smaller satellites, and there's a commercial aspect to space that is growing from year to year. And also in lunar exploration, there is already a commercial side to it and commercial interest. For various reasons, because some resources on the Moon, there are some resources that can be exploited to help spaceflight activities, for instance, like making rocket propellants on the Moon and so on.
Yeah, that's really great. And yeah, if you can start with your presentation, then.
Yes. Okay. Fine. Anyways, yeah, the Q&A window is open all the time, as Lyubomir and Nadia have been explaining. Right. Yeah. I will, let's say, talk a little bit about the so-called lunar economy. It's a grand term, but I hope to be able to convey, let's say, the current trends in the exploration of our moon. And you see here a nice photograph showing the Earth and the moon taken in the same image by...
Sorry, Lutz, you're not
Yes.
sharing your screen.
Ah, I'm not sharing my screen. Oh, good point. Good catch, Lyubomir. Thank you. Yes, we tried it before. So this is the command. Okay. And now, yeah, okay. It's coming across, isn't it?
Yes,
yeah.
That's great.
Okay, fine. Yeah, this is a nice photograph that I put on the title slide. I think it's nice because it shows the Earth and the moon together in a single image, taken by a planetary deep space probe a few days after it was launched from Earth, already in 1977, a long time ago. But after astronauts traveled to the moon, the final time that happened was 50 years ago in 1972. Yes, so let's get us started in this talk. Now, in the image here on the top left, this is a nice depiction, I think, of the relative sizes of the Earth and the moon and their distance, because this really shows the situation to scale. So the diameter of the Earth is like 4 times larger than the diameter of the moon. And also the two objects are shown in that figure with the correct distance to each other, fully to scale. So around 400,000 kilometers distance between the Earth and the moon. The orbit of the moon around the Earth is slightly elliptical, so the distance varies. Okay, but it's not, in planetary exploration, it's not very far, because the time that the light travels or radio waves travel between the Earth and the moon and the other way around, it's just 1.5 seconds, 1.3 seconds or so. This is important also for robotics on the moon, because of this rather limited distance and the short latency in the signal transmission. It's possible to remotely control things from Earth that are on the surface of the moon with very little time delay. But this is just a side aspect here. And then some nice photographs here from the Apollo era, when astronauts traveled to the moon 50 years ago. Was the last time this happened on Apollo 17, was the final Apollo mission, so spectacular scenery. Yes, the Apollo era was really special because it was the first time that humans traveled from the Earth to another world. The moon is another world, of course. So this is really in the history of humankind. It's a very particular moment. And 6 missions landed successfully on the moon with astronauts. And it was also a time when there was the so-called space race between the United States and the Soviet Union at that time, who would be the first to send astronauts to the moon. But also the Apollo program, so a number of missions, delivered some very important scientific results. It was politically important, yes, also technologically important, but also important science results were delivered by doing geology on another world. So the astronauts were trained to act like geologists, selecting samples and which were returned to Earth. So it was possible in labs on Earth to understand a lot about the composition of the moon, the formation of the moon, the age of certain areas of the moon, because this you can measure in the laboratory on returned rock samples, for example. And then some long-lived measurement stations were deployed and left behind on the moon by the astronaut missions in the Apollo era. So a very important time, again, about 50 years ago. And this allowed to establish, let's say, very distinct knowledge about the moon, how it formed most likely. Some of the things were already known before the space age. For instance, that the terrain on the moon, there are two major different types, so-called plains or mare, they're called, and then highland terrain and mare are relatively younger. There was lava that was pouring out in the past after large impacts, and the older material is the so-called highlands, and the composition is very different, and missions have landed on both the mare and on the highlands. And then we have detailed maps of the composition of the lunar surface, where the composition is mapped with lunar orbiters or lunar satellites, also in recent years, that allowed to map certain minerals where they are distributed on the moon. And there is a big difference between the so-called near side of the moon and the far side. Because the near side has this mare and the far side basically no mare, but the older highland type terrain. Anyways, no, it's certainly a very diverse body that was very active in the past, with some internal activity and magma rising to the surface and flooding certain plains, and no air, so there's vacuum, and so a lot of very old materials are found there. So from shortly after the formation of the moon. So the moon is an interesting place to sample very old materials from the time when the Earth, shortly after the Earth formed. And then the polar regions of the moon are quite interesting. This was only appreciated in the last 10 or 20 years. Because of the topography of the polar regions, there are craters, and because of the orientation of the spin axis of the moon, there are craters or depressions where the sunlight never enters. And there is a nice photograph here shown in the middle of this slide, taken from a lunar satellite about 15 years ago. Japanese lunar orbiter mission showing the South Polar region and the Earth in one image. This is not a montage. This was the scene. And no, just to illustrate the topography of the polar region, where the South Polar region, where there's a lot of shadows, the sun is very low on the horizon, and there are craters where the interior is never illuminated by the sun. And it was found out by instruments on lunar satellites that in these dark areas, but in general in the polar terrains, there is an enrichment, a higher concentration of hydrogen, which is indicative of water ice, and a higher concentration of other volatiles. There also was an impact experiment that was conducted more than 10 years ago to impact a rocket stage into one of these permanently shadowed regions, or one of these dark craters, to release material that was then observed. And it was inferred that at the impact point, about 5 to 10% of ices were mixed in the soil. So in other words, we now have an understanding that in the polar regions, there are concentrations of ices, also in the North Polar region of the moon. But no mission has so far landed in the polar region. So all of these observations are from lunar satellites, and in some way indirect. So it will be important in the future to land there and to analyze and to really measure the concentration of the ice and to understand if it can be extracted or not. So in recent years, important progress was made in lunar exploration by, on the one hand, satellites, so lunar satellites, lunar orbiters. And then the Chinese space program has been very important with regard to lunar exploration. And as I will show in a second, and then new crewed spacecraft have been developed or are being developed to again send astronauts to the moon. And there are plans for long duration presence of astronauts on the lunar surface. So, but let's start with the so-called modern lunar orbiters. So lunar satellite missions of recent years, let's say of the past 20 or 30 years, that were able to fill gaps in our knowledge of the moon, gaps after the Apollo program. So the Apollo program sent astronauts to the moon, yes, but only to 6 locations on the surface. Some measurements were done from lunar orbit, but not covering the whole of the moon. And these recent lunar orbiter missions, they were in polar orbits, they mapped remotely the composition of the surface using multispectral imaging, using gamma ray, neutron spectroscopy, and other techniques. And they also provided this indirect evidence for ices at the lunar poles, and also geophysical measurements from lunar satellites, like mapping to high accuracy the gravity field of the moon, which is important for various reasons, also to understand the internal structure. And just a few weeks ago, the recent lunar satellite was launched by South Korea. So it's a South Korea mission shown on the bottom left of this slide. The Danuri lunar orbiter mission was just launched a few weeks ago. Yes, so, and then the Chinese program, as I mentioned, the Chinese space program has been putting a focus on lunar missions. Of course, in China, they have this long, these 5-year plans and long duration planning, and then they work according to this program. And they've been very successful with that. And China has been the nation that achieved the first landings on the moon without astronauts since the 1970s. And so they first had 2 lunar satellites, and then they had a first lander mission with a rover called U2 in 2013. Some images shown on the top right, this Chang'e 3 mission. And then an identical spacecraft basically was sent to the far side of the moon that we cannot see from the Earth, because the moon is like locked in rotation. So the moon is showing us always the same face. But the Chang'e 4 mission was sent to land a lander and a rover on the far side of the moon in a geologically interesting area. And the Chinese, they used a dedicated relay satellite positioned in an orbit around the moon to relay communications from Earth to the far side. And this mission also has been very successful. And then they did a sample return mission without astronauts, a Chang'e 5 mission about 2 years ago, shown at the bottom of this slide, where they landed and sampled soil using different types of mechanical devices, a drill, and then a scoop-like system that you can see on this slide, to deposit it into an ascent vehicle that was launched from the lunar surface, and then made a rendezvous in lunar orbit with the satellite, and it returned to Earth and delivered the samples successfully to the Earth's surface for analysis on Earth. So China has been very, very active here. But then there's also commercial lunar activities, as was mentioned a couple of minutes ago. And let's say the lunar economy will have a strong element of commercial lunar activities. And what are they? So as opposed to a space agency developing a spacecraft, sending it to the moon in this case, there are now quite a few companies, mainly in the United States, but also in Japan and also in Israel, that are developing small landers to go to the moon to deliver scientific instruments, technological experiments to the lunar surface. And let's say the first example of such a mission was really the privately funded Bereshit mission of Israel in 2019. They started under the Google Lunar X Prize, basically, and were the only team that really launched their mission even after the prize had expired. And unfortunately, the mission was not fully successful. I mean, it was successful in transferring from Earth orbit to lunar orbit and then the lunar orbital phase. But then during the final descent to the surface, a commanding error from the ground led to a crash of the spacecraft, unfortunately. Yes, and in the US, there are a couple companies that are now getting ready to launch their first small-scale lunar lander missions. Like Intuitive Machines is the name of one company, and then Astrobotic is a separate company. And they are acting currently under contract, partially under contract from NASA. Like 50% of the mission is paid for by NASA, and the rest they raise with private funding. And in the long run, they hope to become independent from NASA as the customer. And these missions are not so expensive. So each one of those missions in total is like $120 million, including development of the lander, initial development. And iSpace is a company based in Japan. They're also getting ready to launch their first lander mission just in November. So next month, basically 2 months away. And they are fully privately funded or by investors. And in the future, there will also be lunar satellites developed and launched on a commercial basis, because they will offer services like navigation services and communications relay to be used by unmanned, uncrewed missions on the surface of the moon, but also by crewed missions later on with astronauts. So there will be a need to determine your position on the lunar surface, like we use here on Earth with GPS and Galileo, and to do that also on the moon, and also to relay data and communications from the moon to Earth. So there is more coming. And then on the other hand, there's a new crewed lunar program in preparation, led, I would say, by the United States. That's the Artemis program, which has now completed development of the large SLS rocket with the Orion spacecraft to take people from the Earth to lunar orbit. And in parallel, a small space station is being developed, the Lunar Gateway. You see some images here on the left that will orbit around the moon. And also a lander spacecraft is being developed to take astronauts then from lunar orbit to the surface of the moon. And the first mission of, yes, the SLS with the Orion without astronauts, you have been following it probably the last few weeks and months. There's ongoing delays with launching this rocket for the very first time, where we hope it gets off the ground successfully still this year. But development is fully completed. Yes, and then there will again be astronaut missions on the surface of the moon, but not just short duration missions, but the idea also in the Artemis program is that like an outpost will be established on the surface of the moon near the lunar South Pole, the so-called Artemis base camp, which would be occupied by astronauts always for certain amounts of time. And in parallel, also China is working on astronaut landings on the moon. So far, as you've seen, they've been successful with uncrewed missions, and they are, however, also developing a relatively large rocket and a new crewed spacecraft, and they have a plan to establish also a crewed outpost on the lunar surface, also near the South Pole of the moon. Yes, and the South Pole of the moon is really interesting, again, because the lunar orbiters suggest that there are sizable concentrations of ices in these permanently shadowed depressions and craters. So you see here on the right-hand side, these shaded squares or rectangles. These indicate planned landing zones, planned landing regions of some upcoming missions, in particular for the first astronaut landing in the Artemis program. So these are candidate landing sites that are close to such permanently shadowed craters, but still in direct sun illumination. But you could move there from there with a rover or with a robot or something else to get into the darkness and do some measurements there. And this is also the planned location of these outposts or crewed stations on the surface of the moon. And there will be also robotic missions going to this general area before astronauts land there. And on the left side, you see the scenario for the so-called Viper lunar rover mission, which is a NASA mission that will launch in about 2 years. And that rover will also land in the South Polar region. It has a drill to take samples and to analyze the samples on the spot to look for the ices. So that would be one of the first missions to land in the South Polar region ever, and to try to measure the nature of these ices and the composition, because the ices are also believed to be present under the dry soil in regions that are illuminated by the sun. So you don't have to necessarily enter into the darkness, and this needs to be understood properly, how these ices are distributed. And why are these ices interesting? Well, I mentioned it in the very beginning. If the concentration is sizable, if it is significant, which has to be confirmed by the initial landing missions to the polar regions, then it would be possible to mine the ices, to extract them using various different techniques that are under development. And these ices you can, for instance, then split into components like hydrogen and oxygen, which are rocket propellants. And this whole concept of using local resources on the moon is also called in situ resource utilization. And why is it important? Because you can make rocket propellants, and for astronauts, you can make also breathing gases from these ices without bringing these things from Earth. So the effort to bring rocket propellant, oxygen is very much reduced if you can make these materials on the moon, on the spot, and then use that to get back to Earth. You can set up like propellant depots on the lunar surface for refueling of spacecraft. So that will become very important, and that's also the idea behind the long-term presence of people, of humans on the lunar surface in the future. So as opposed to Apollo 50 years ago, now this time it will be a sustainable presence, as it's termed, because you would make use of local resources. So in this whole context of commercial lander missions, and then later on followed by making consumables on the moon, is an important element of the so-called lunar economy. And we see record investments already today by venture capital, for instance, and other private money into companies, into startups that promise to be active in the lunar domain, let's say, because there is this prospect of a market. So quite a few companies plan to offer commercial services like communications relay, like mining resources, like producing rocket propellant that promise to make a profit by selling these commodities to space users. And that's important. That's also highlighted on this slide. It's unlikely that things can be extracted on the moon and taken to Earth to be used here on Earth as a resource or as a raw material, because it takes a lot of effort to bring things from the moon to Earth. Instead, the if you do the economics of let's say of future moon exploration and the commercial elements of it, then it's clear. Then you have a business case if you extract resources, make them usable, and sell them to spaceflight users, sell them to actors, to companies that need to refuel their spacecraft in space and do other things. So that's really the market, the in-space market, let's say. It's also shown here 4 different possible uses for materials that could be produced on the moon, and only one of these 4 would be to sell such materials for use on Earth. So that's really the extreme case for very valuable materials. For instance, in the past, helium-3, which is an isotope of helium, 30 years ago was already suggested as such a commodity that can be used on Earth for nuclear fusion reactors. But there are very, very rare exceptions of things that you could mine on the moon, bring them to Earth. Rather, the case is really making things on the moon that you sell to actors that already are in space or in the lunar environment. Here are some examples of how a propellant production, rocket propellant production, or oxygen extraction could work on the moon. On the left-hand side, you see a scenario, an artist's impression of one of these craters, the interior of which is shaded, it's not illuminated by the sun. And there are devices that would, by thermal action, sublimate ices that are present under the surface, and they would be captured, the gases, and turned later on into hydrogen and oxygen, for instance. On the right-hand side, you see a field test of a prototype oxygen extraction system, field test on Earth. Oxygen extraction from the dry soil, because even if you don't have ices away from the polar regions, you have mineralogically bound oxygen in the soil of the moon everywhere to more than 40 weight%. And it is possible to extract it, but with a high temperature process of like 1,000 degrees centigrade and bringing some reactant gases. Anyways, no, it's undeniable that in just a few years from now already, there will be a demand for consumables made on the moon, a demand by spacefaring actors, by companies, but also by governments like the US government. There will be a demand to buy, for instance, rocket propellants that are made on the moon. And there are even plans to establish depots of such propellant in the near lunar environment, like in an orbit between the Earth and the moon. And yeah, this table shows like the types of rocket propellants that are used by different types of spacecraft and by different actors, and what their characteristics are. As you see, there are a lot of companies that are active already in the lunar market and the lunar economy, and they will have use of such propellants. And these tables, they depict in tons the predicted or expected demand for lunar produced rocket propellants. You see, even in the period in this decade, there is a predicted demand of a few tens of metric tons, empty metric tons, of propellants to be made on the moon and to be transferred or acquired on the lunar surface. LS stands for point of sale. So if somebody is able to make it on the spot on the moon, they will be able to sell it on the lunar surface to refuel spacecraft that want to again get back to Earth from the moon. There's already in this decade, there's a sizable demand. And then that demand is predicted to go up in the next decade and after that, of course. Yes, and all of this, let's say, new world in lunar exploration and lunar also exploitation will have many aspects related to robotics. That's a good news for us here in this webinar, in this forum, because most of us are in some shape or form interested in robotics. And because all of these scenarios, they will require robotics. For instance, there will be more lunar rovers in the future. Not just very tiny ones. There's an example shown here, like a so-called cube rover by Astrobotics, which is like just 5 kilograms in mass. So the companies developing such tiny vehicles. However, there's also going to be very large rovers for astronaut transport and pressurized rovers. So with a crew cabin under convenient temperature and pressure conditions, like the Japanese concept shown here on the top right. So such vehicles will be developed, will be brought to the moon. Then also excavation and sample handling and soil and ice handling equipment also broadly is referred to robotics, because a lot of that will have to be automated. These mining operations, imagine they will require different techniques of mining, some mechanical mining types, but also thermal mining, where you heat the surface and capture the gases that come off. And all of that, or most of that, will have to be automated with let's say, autonomy and local intelligence, and also moving mechanisms. So that's also a robotic domain. And then for exploration, for scouting, for surveying, let's say at the regional scale, there will be a new class of vehicles on the moon that would be either hopping or flying, controlled flight. And since there is no air, I mean, you can think of mechanical hoppers. There are interesting developments ongoing, but also vehicles that use small rocket engines or thrusters for controlled flight. Again, we cannot use rotor-driven drones because there's no air, so you need rocket propulsion, but the gravity is low. It's just 1/6 of Earth's gravity, so it's not too difficult, and there are ongoing concepts and developments for such lunar drones, as they're called, and they will become very important in the future to reconnoiter, let's say, the permanently shadowed craters, to get to fly into their interior, to touch the ground, to look for the ices in detail in the dark, but also to explore other things on the lunar surface, like geological formations that cannot be accessed easily with surface rovers because the terrain is too rough, and also caves. There are caves on the moon, like lava tubes, the interior of which can be explored with such rocket-propelled drones. Yes, this is the final slide already. So basically so we're looking at a timeline of really commercialization of many aspects of, let's say, the space between the Earth and the moon, including the lunar surface, over the next 20 to 30 years, where more and more activities will take place to make the exploration of the moon sustainable. So to keep astronauts there for longer periods of time, using local resources, breathing gases, rocket propellants, to also lower the cost of lunar exploration. You do not have to launch everything from the Earth. So exploitation of resources on the moon will become very important, and there is a big market behind this. And the moon, not to forget, will be a staging ground also for crewed missions going to Mars in the future. Right, this is the final slide. No, actually, it's not yet the final slide. So you see my contacts here. Yes, I'm happy to support SoftServe in the space robotics domain. And yes, thank you for your attention.
Thank you, Lucius. It was really a great and insightful presentation. Lots of new ideas that can be taken out of it, and I hope that really hope that in the nearest future one of the robots that operate on Moon will be there with the help of SoftServe. So we have several questions here in chat, so you can type your questions in Q&A, and there are several of them here. Now, I have a great news that the chat is already working. You can check it, and I see that there are some raised hands. So I will be able to unmute you, and you will be you can voice out your questions. So let me start from the questions from the Q&A part. So the first question to you, Lutz, is what are the timelines for first manned mission and landing?
Right. Okay. So on the US side, let's say in the Artemis program, this first flight of the large new rocket, the Space Launch System with the Orion spacecraft without astronauts has to be successful. This was now delayed again the last few months and weeks. If that is successful, then the first mission to lunar orbit with this system will take place with astronauts about 1 year later or 1.5 years later. And then the first landing with astronauts is currently planned in the Artemis program led by the US, currently planned for not earlier than 25. So it may, if you ask me, it's going to be even 26 or 27. Yeah. But not too far from now. So again, astronauts in lunar orbit 2 years from now. And astronauts again on the lunar surface 3 to 4 years from now. Ljubomir, you're muted, I think.
Yeah. I was asking whether you think that we should all plan our vacations somewhere on the Moon in the nearest decade.
It will happen. It will happen. Like we're seeing space tourists to going to the International Space Station. That has been happening for more than 20 years now. Yeah. And also it will happen on the Moon, but at least another 10 years from now.
Okay, great. So before I will unmute Pavel, let me ask another question from Q&A. So can you please tell about space junk and its impact on mission launches?
Yeah, no, certainly. I mean, space junk is really important around the Earth. So in orbits around the Earth, there are now even thousands of active satellites. Think of these mega constellations like Starlink, and then OneWeb are also doing their own constellation. And then also satellites that are already dead. So around the Earth, it's becoming a bit critical because if some fragment impacts a larger body, then the larger body, the larger satellite or whatever can disintegrate and create thousands of smaller debris. There's this movie Gravity that explains this in a very good way, so that it can lead to a cascading situation. But this is really a problem in around the Earth. And yes, these objects are tracked from the ground with radars, for instance, to high precision. So you know where things are, and you can maneuver active satellites to avoid certain collisions. But some things cannot be predicted, or some objects are too small, and you cannot do anything about it. But then for lunar missions, it's not a problem because there are just very few spacecraft around the Moon or in the vicinity of the Moon.
Mm-hmm. Okay, great, thank you. So Pavel, I'm going to unmute you and you can voice over your question, please.
And I will stop sharing the screen, perhaps. Okay.
Okay, Pavel, you are muted. So if you are ready, you can voice over your question, please. Okay, so then if not, let me jump to Q. Oh, I see the question from Paul here. So the question is, which areas of space robotics are touched with SoftServe projects? And I guess that we can combine it with the other question. Well, all your work is focused on lunar exploration. Is it possible that you were also interested in other planets as well? So yes, we are interested not only in lunar exploration. We are we are looking into also a project that are connected with satellites, Mars exploration, and other objects that are there. So we are not definitely limited to the moon. Maybe you want to add something regarding your expertise. I know that you have something that you can add here.
Maybe asteroids we could add. Asteroid
Yeah.
missions also, yeah, because there are a number of missions that are landing, not just impacting asteroids like we've seen this week with DART, but also landing on asteroids. And there have already been hopping robots on small asteroids, and there will be more in the future.
Yep. The question is, what is the best way to join this moon race for a software developer? Is it just robot building? So, well, I believe that there is a room for software and hardware developers, and I believe that there are multiple ways to join. For instance, I know that if you're talking about satellites that are circulating around the orbit, so there is a huge demand for image analysis and data analysis that is streamed to the Earth. So it's not only with robots, but if you want to get to the other planets, so robot or spacecraft is something that has to be there. Any comments from your side to this question, or?
No, I think it's just right what you said, Lubomir. Because SoftServe is focused on let's say software and therefore autonomy and robotics. That would be the most appropriate answer, I think. Yeah.
And there is another comment. Thank you for your reply, and thank you for very interesting, informative, and interesting presentation. So that's to you, Lutz. And we have maybe some questions here.
Maria was asking, what is the relevance of this topic? Okay, no, it's clear. I mean, the scope of this event is really to say what SoftServe is planning to do in, or to give an example of what we're planning to do in the space domain. And lunar exploration, for instance, is one example with robotics. And then in the next talk that we will hear about like satellite technologies and aspects of small satellites. That's also very exciting, and that's also a possibility also for SoftServe.
Okay. Great. So let's have a few more questions, and then we can switch to the next activities that we have. Please take my Ukrainian in your comment. There are a lot of smart and professional engineers here. So in fact, our robotics group is in this group, there are people from Ukraine, Poland, and we are not limited to any country. So we are actively looking for professionals in different countries, including Ukraine. So no doubt. And do you need test automation engineers here? So people want to go on site and test some robots on the moon for sure. So I believe that the test automation is a crucial part for the missions, because due to the price, so the quality should be on the certain level, and yeah. Which which you will protect a camp from. Okay, I don't think that I understand this one. Okay. The question is, isn't there also a possibility for analytics and advanced calculations or simulations for space activities? And in the brackets is added thinking of Omniverse simulations. I believe that it's about NVIDIA Omniverse simulations. Do you want to answer this question?
Yeah, I could. In the sense that we need simulations for the proper design task, let's say, the answer is certainly yes. So developing a space system, especially a space robotics system, always by default has to involve simulation to be able to optimize or to define the control system and to rehearse things as well later on. But of course, it cannot be a replacement for doing the real space mission. I don't know in which direction the question was going. Lubomir, you muted.
Thank you. So
it happens to everybody.
I was saying that we have a couple more questions in the chat, but since the time of the event is limited, and we have some activities to here also to now, so let's try to answer these questions offline. And now we have a quiz. That I invite you to take part in. So it's a Kahoot quiz. If you are familiar with this, so there will be a couple of questions, and a person who will be the best one in answering this question will have a prize. So it will be SoftServe merch, and so there are 6 questions. What counts is the correctness of your answer and also the speed of your answer. For each of the answer, you will have some points assigned, and there will be 3 winners. Now, what I would like to ask you to do, so now in a second you will see a QR code. So please take your phones and scan this QR code with your phones. You will be provided with a link. So there are 2 options. Either the link will be automatically opened in your browser, or you will have to copy this link and paste it in your browser. Then you will be asked for a nickname. Please use the nickname which would help us to identify you among the attendees of this event. Because if you will be a winner, then you would like us to send the prize to a correct person. And additionally, so for those 3 persons who will be the winners, please type the word winner in the chat. So again, for us to make it easier identify. So I'm going to press here start. In a second, you will see a QR code. Can you see it? Now, and as you can see a QR code, please open your phones and scan it and enter your nickname. And so I will be able to see how many people are here. And so I'm waiting for you to join. So we have Ihor, we have MK, great. Let's wait. So there were like almost 100 people attending this event. So let's give it a couple of minutes to for all of us to join. So we have Grzegorz, Alex, we have Lukasz Czyż, great. We have Oleg K. We have Jakub Tom, Great. We have Darina Green. So 22 people joined. 23. Let's wait. Okay. So just and very important information. So you will see these questions on the screen that I'm currently sharing, while you will use your phones to answer them. So it might be a bit confusion at the beginning. This is why I'm pointing this out. So the answers should be given on your phone. It's useless to press anything on your laptop. So hold your phones in your hands to make sure that you will give the fastest answer, because the speed of your answer also influences the amount of points that you will get. So 37 participants, great. We have Anton P, Victor, Oleg Patsula, AK, Nazari. So let's wait for a couple more seconds and then we can start. Okay, 30, 39. Let's make it 40, 40. So let's start. I'm 41. Okay, 42. Okay. A couple more seconds. 44. 5. If I started earlier, we could have lost 5 people. 47. Oh, that's great. Almost half of the attendees. Great. 48. Cool. So Kuzik, Kill Putin. I like that nickname. Andrei R. Mikhailo Bronek. Okay. 50. So we have 51. Great. Valentin just join us. Okay. So 5, 4, 3, 2, 1. Start. So now there is a quiz. You will see first the question. You please read the question and then the answers will appear. Please give your answers and you have 30 seconds. The time is on the left. Okay. Good. So the correct answer was meteorite, and we have 33 correct answers, which is great. Now let's see the scoreboard. So the first one is Max K, then Max Mik, and Ivan SH. And the latter two have the same amount of points. So let's move on to the next question. This is the question. Now you will have 30 seconds to answer. Yeah, and the majority gave the correct answer. So it's about 3 days to get to the moon. Of course, the duration depends on the trajectory that is selected for the specific aircraft, but at the first test, the fastest we can get there in 3 days. So let's move on to the scoreboard, and the result changed a bit. So now we have Markian, the first place. The second place is Ivan SH, and Andrei R is the third place. Okay, let's move to the next question. hear the question, and you will see the answers soon, and 30 seconds for those answers. Perfect. Guys, you are great. So we have 31 correct answer. This is amazing. Yes, it's a really geostationary orbit. So this was really a correct answer. And yeah, let's see what is our scoreboard. So Markian is a leader, the second round in a row. Okay, we have Air Magna SoftServe with the second one, and Ivan SH. He is on the third place. So again, the second round, or even the third round in a row. That's great. Let's move on to the next question. And 30 seconds for the answer. Perfect. Ha, great. So it's even better than the previous time. So yeah, though since we should need some let's say air or fluid in order for sound to share in it. So and there is we have vacuum in the space, so we cannot hear any sound there. Right. So this was the first question out of 6. Let's see. Markian, you have 4 correct answers in a row. That's great. You're a leader, but Air Magnat SoftServe is close, and Ivan SH it's still on the third position, and so it's a very tough competition. So two answers ahead, and let's see how it goes. Okay, now so there were 12 humans who walked on the moon, and we have like some amount of correct answers, which is great. Yeah, so hopefully that soon this number will increase as those lunar missions that Lutz spoken about will be a success, but for now we have 12 of them. Let's see what is our list of leaders. Oh, and we have Air Magnat SoftServe as a leader. Ivan SH moved to the second position, and we welcome PKIC to the list of the leaders. Markian is on the fourth position, so yeah, he still has a chance, as there is one more answer left, and AMM he is also, or she is also close. So let's see the last one. So an answer, 30 seconds, and we'll see the final position. Yeah, so the mission lasted for 15 years. Instead of 90 days, mission lasted for almost 15 years. And I'm, by the way, happy to say that Lutz was one of the person who was in charge of that mission. So that's kudos to you. 15 years instead of 3 months. This is something unbelievable.
Yeah, it turns out the most difficult thing is the landing on Mars missions. And once you're on the surface, then if the design is correct for thermal survival and power, then you can go on to live for a long time. But still, it was a remarkable achievement. Yes.
Yeah, that is great. And for this is the event or the project that helps you to be a part of human history, because not anyone anyone could have such achievement in his CV, let's say. Okay, so now I'm going to switch to the scoreboard. We will see the final list of the leaders. And again, if you are a winner, please type a word winner in Zoom chat in order for us to make it easier for us to identify you and to ensure that you received the prize. Let's move on. So congratulations to P-Kick, Air Magnet SoftServe, and the winner is Ivan SH. Wow, incredible! Yeah, so congratulations, guys. That was great. It's remarkable how great knowledge in space domain you have, and so again, please type the word winner in chat, and we will contact you, and then we will keep in touch to make sure that SoftServe merch will reach you. Great. So let me then stop sharing, and so yeah, and as we have spoken previously, SoftServe is interested in rovers, drones, satellites, and with this being said, I'm happy to pass the mic to Dmytro, who will present a topic about satellites and how I believe if you're talking about some satellites from commercial components, how it will be soon easy for us to buy our own satellite to watch our garden from out there. Dmytro, mic is yours.
Good evening, everybody, or good night, as American people say in that time. As Lutz mentioned, space is very expensive. Most expensive single thing which we have in the world is International Space Station. It cost more than $150 billion. So in 2004, one guy in NASA, one tester engineer, it's not QA in like in software, it's some guys who are responsible on testing devices, just forgot one thing, and it cost for NASA just one nut was not prepared for testing, and it cost for NASA more than $100 million, only one small nut. So really it's very expensive. But since the beginning of history, we have situation when some very simple, not expensive things make very important change. In 60 1962, one how to say it, enthusiast of photography and astronaut Walter Schirra just took their private camera Hasselblad and just to test it in Mercury mission. If you remember, it's like first missions US in US with human participation. So and they made a few pictures, and NASA very like these pictures and start to using this camera. And this camera made most famous pictures from space. You can see it on the left side. So first step on the moon and Earth rising. So these pictures was made just because one enthusiast just want to try his personal camera in the space. And all times NASA use some commercial product for make pictures, for get evidence that people are present in outer space, in space. So, and for example, more than 200 cameras, Nikon's was used since 30 years, and in these years, NASA again ordered 6 more just commercial camera only, but of course some interesting things. This cover, the suits for camera cost $20,000. It's from Kevlar, but camera is used the same as you can buy in your store. Very good example. Everybody know Planet Lab. It's a company which provides images for Google Map. Everybody use it. Oh, sorry, I another slide. So as an example, you can launch your smartphone in space, and we have a few smartphones which work still in space. It's Google Nexus, Xiaomi, and special PhoneSat. It's like a project from NASA where used some popular smartphone, and you can see that it can get us not bad pictures. And again, this camera costs like $100, and it's not so much like, for example, a special space camera, which price starting from $50,000. So just your smartphone able to work in space. You just need to try it. And back to Google map services. So the first satellite which was used most for proof of concept. They include security camera from IMREX. It's like industrial security camera, not special, and commercial optics. It's like mirror optics, which have some advantages instead using lens, but really total cost of this camera and optics is about $1,000. And they made 3U, very small CubeSat. It's only 10 on 30 centimeters, and it will be enough to provide services for Google, and Google made a very good agreement with Planet Lab, and Planet Lab still provides a lot services for a lot of companies. So it's one of the leader of market, but they started just from commercial hardware. Laptops. IBM provided first ThinkPad laptop for NASA. On International Space Station, we don't have any like special switches or other elements for controls. Only laptops used for these purposes. Since International Space Stations exist, NASA bought more than 750 laptops for each astronaut has more than one laptop just for control International Space Station. And very interesting fact that IBM ThinkPad was first laptop in outer space. It was used for fixing problem on Hubble. So it was in outer space, and this laptop is almost same as we can buy in shop. But the last 5 years, astronauts start use iPad. Of course, it's more comfortable than laptops. And since last year, iPad use it not only for entertainment. First one was for promoting Angry Birds, just for playing games. And but since last year, it also used it for control some systems on International Space Station. So you can buy something what use it in most expensive space device in space. Of course, GoPro. GoPro used SpaceX, Elon Musk, SpaceX since beginning. We saw a lot of pictures from the second stage of rocket, how to we have we can see first stage from second and second stage from first, and usually for these purposes use it GoPro camera. You can see some like history of this using and how it exactly mounted on stages. And in this year, GoPro was launched with COPSAT, one European startup, and you can see how Nano Avionics made pictures from GoPro in open space. So again, there are no any like special change in this device. It's serious devices, and you can use it for make something incredible. And it is not from NASA, it's from our team. So we also used GoPro camera. It's GoPro Max. It makes 360-degree pictures and videos. So we launched it for rocket delivery company. It was first fly of 360-degree camera in Europe, and we made very great pictures. Now video with this launch on YouTube view it more than 1 million times. But how we started, how we get something like this? Our team started from stratostats. We try to do some small airship, which has some advantages instead drones. It's very silent and it has a long term flight, and it looks like UFO. Alien device from alien. So just it was like crazy idea, but with this idea we won a few competitions, and one of competition from Europe Space Agency provide us possibility to visit Toulouse and see on other project, and we was shocked because for us space is something very expensive. Only billionaires or government can play on this market, but we saw that a lot of people from schools, children try to do something related with space in Europe. So we like it was exit from our bulb. So, and we understood that we can do something with space related, so it's possible. Also, if you do something crazy like this aerostat, you can touch with some very interesting people. First picture we got in Dnipro. It's like space capital of Ukraine, Dnipro city. There are some very famous industry and factories what made a lot of space devices in past in USSR time. It is Yuzhnoye and Yuzhmash, and now in Dnipro there are a lot of space startups. In 11 hours we can see launch of Firefly rocket. It is US startup from USA, but really a lot of Ukrainian people involved in developing this rocket. So good luck, Firefly company, which will run this rocket. So second picture we got it's with Adam Savage in US, but the main idea, if you do something amazing, it's not only like useful, it's also funny, and I will confirm it a little later. So it's some pictures from our missions. We had 6 launches in stratosphere, and all were successful. Why we use stratosphere? Because it's like you can reproduce space environment, but payload you can back payload without crashes and without a lot of expenses. And it is very good for some biological and physics experiment, for some research of our environment, for ecological direction investigation. So it's very useful for science. And each of our missions includes some science equipments, and as I said, we have 6 successful missions, and but we didn't lost any our payload. But after second successful mission, I decided, okay, I am thinking that it is not possible to continue to have successful missions. So we had like a commercial mission for company SpaceBit, which now working on lunar rover, which has hands. It's like a small web for discovering some tubes on the moon. So, and I am very carried about this, that we will lose some very important science equipment for this mission. Therefore, we launched 2 stratosphere satellites with equipment, and I was very surprised because we found both of them. And now I'm trying to present video from this mission. I just make it more quickly. So this is a launch. We used meteorological balloon and helium, filled by helium. Just waiting launch. The balloon start up with velocity about 5 meters per second. On the altitude about 30 kilometers, it breaks up because on this altitude the pressure is like on Mars. It's about 1% of pressure on sea level, and pressure inside the balloon very high, and balloon breaks, and then it landed by parachute. During this mission, the balloon, the payload, found payload in 30 kilometers from launch point. So that's all. And in generally, it's sorry, stop it. So it's very difficult. You should prepare payload, you should prepare a mission, then you are waiting about 4 or 5 hours, and going to 300 kilometers, try to find it in the field on some wood. So it's like it's very hard and very complex task, but it is funny because that launch we had on Halloween, and we got data from our payload, and looks like it was on the tree because it was 10 meters under the earth, and so on Halloween we looked like this. It was very funny because it was like on the road, and cars would pass us, stop it, ask it, what is this on Halloween? But you can get very great pictures. So and you can see that we have very thin atmosphere, and we should think how to save this atmosphere and our environment in generally. So this is moment when balloon breaks up. And a little bit about technical details. So it's is our controller. It was designed by Ukrainian developer and Alexander, who did it now on this meeting. We have everybody was, I think a lot of people had fly by airplane and see the temperature on 10 kilometers is about -50, -40, but on 30 kilometers we have temperature about -71 Celsius, and pressure as on Mars is only 0.1 of 1%, and after a few first mission, we saw that our we have -71 degree, but really all electronic devices was heated. Was very warm during mission. So we have some temperature sensors. Because there are not enough air for cooling. So it's we have -71 degree, but we should think in how to cooling our devices. It's something was a surprise. Also, we cannot use a lithium battery. We should use some special battery. It's from with titanium or with ferrum, because this battery able to alive extreme conditions. We cannot use like commercial GPS with basic firmware, because it turned off at 16 kilometers. It's by design, and you should update firmware, not update, just change some parameters, and then you can use it for for fly higher than airplanes. So it was surprising, something new for us and for people who working with GPS. So because airplanes don't fly so high. Also, we have some problem with cables. We should use only silicon cables because all other cables are can break up very easy in extreme conditions. As I said, but also we was very care about our payload because some very important scientist equipment we launched. So, and we made some equipment for testing for reproducing environment in high altitude, and I will show you a quick video. So here is very small balloon and water in in normal condition. This is vacuum chamber and vacuum pump. And very quick, really, this video it's about 1.5 of hour, but I try to show it in 8 seconds. I stop here, so we just pump down pressure, and balloon. So it's we reproducing how to balloon increase volume in stratosphere, and here you can see little bulb. So water in normal temperature start boil it because very low pressure. On it again. See people very quick moving here because. So we have like special vacuum chamber for reproduce this extreme environment. As I said, launch it's very hard, but it's very interesting, and a lot of people want to like be part of this, but cannot because they cannot spend a lot of days for preparation. So we decided to move something because a lot of people love space. There are a lot of space fans, and we like we try. We try to give something space related for these people who want to touch space but cannot. We made this is a copy of hardware what I saw a few slides ago, but with some general devices, but with absolutely same functionality, and is also it has some functionality like CubeSat. It's small standard for small satellites. Now we have in orbit more than 700 CubeSats. So here is very same functionality on commercial hardware, and also we like made very, as we think, sexy frame, and this hardware now looks like CubeSat. So it's just for space fans. Also, it's for school, coding school, for university, for where people want to learn about CubeSats. We have like so it's like assembled kit, but we provided like parts not assembled, and people who are interested should spend about 4 hours to assembly this kit. Also on video you saw some like we got some numbers with velocity, with GPS coordinates, but it's like some numbers. But people, for most of people, it's not very good to see just numbers. So we also developed some human readable UI for these purposes. Here's a small animation how it works. And what is next? Our plan. Last year we signed agreement with SAND. We plan to upgrade this kit for real CubeSat, and we have agreement with RFA, a German company, a German startup, which are working on a new rocket. So, and also we have idea for moon exploration. The problem on the moon that all small rovers cannot be powered by a radioactive thermal heater system, because before all rovers from NASA, ESA was equipped by this small nuclear power plant. But for small, it's like there are a lot of problems with this nuclear power plant. So most of robots which will be launched this year and next year will have lifetime only 2 weeks by Earth days, and only one sun day, because after 2 weeks with sun on the moon will be lunar night. The temperature will decrease to minus 200, and all devices all companies which work on rovers don't expect that their devices will survive in these conditions. We have some ideas how to survive during lunar night, and we have memorandum with iSpace company, which Lutz mentioned. It's a Japanese company with offices in Luxembourg and US. Not in nearest, but in future, we plan launch our device with this company. But for these purposes, we need to aggregate about $4.5 million per 3 kilograms for our device. So for now, it looks like impossible, but we had experience that impossible could be possible. So we have a dream, and we try to go in for that. Thank you, everybody. I am ready for questions.
Yeah, thank you, Dmytro. It was a great presentation. Now I really want to have my own satellite launch somewhere there. So thank you for this inspiration. And let's switch to questions. So the first question is okay. So we have. What kind of software formalism are you using for implementing autonomous agents, state machines, behavior trees, planners? Dmytro?
It was like functional methodology of programming. We just have setup part where we just configure of necessary hardware and infinity loop, nothing special. We tried to use some operation system, but our missions were not very complicated to thinking about management. Only something related about memory management, about some multi-threading. So we had very simple missions. Only something like sleeping for save energy, use it for it, but no operation system and no any complex approaches for software development. So maybe in future we need it.
Thank you. Thank you, Dmytro. So let's jump to the other question. Who can launch such a balloon that you presented? Is it anyone? Does anyone can do that, or some specific permission is required before launch? And of course, in terms of Ukraine, it's not. This question is not valid in the case of war, but let's assume that after our victory, we want to launch something like that. So. What do we need to do?
Before this active phase of war, we also had a lot of problem with get permissions. So I prepared huge amount of documents because during our flight, all airplanes all know that we are flying, and we should talk with military, with Ministry of Infrastructure to get permissions, and operator of airplanes not very happy when we launched it. So it's very difficult. Also, we cannot fly over the special object like nuclear station, airports. It means that airplanes and drones can work out, but balloon cannot. So we need to launch it only from special place. This place depends from mines. So we military guys provide a few points in Ukraine for us for launching, and 2 times we had rejections because in day of fly wind was very strange, or some important airplanes flight in our area of balloon flying. So we had it's a lot of paperwork for preparation, but in Europe country and US it's more easy for launch something. And in Ukraine we have a lot of payloads from Poland, for example, because in Poland more easy to launch something. It's like we have in Ukraine we have legislation from USSR time, but in more progressive countries there are more easy way. Therefore, a lot of children from schools launched something like this. But we expect that it will be changed.
Thank you. And the next question from Victor. Also, normally standard electronics components, like you shown, are not intended to work in so cool environment. How is it possible to keep normal operation for them and be sure it's okay?
Some commercial components able to work in extreme conditions. They have thermostabilization. So, for example, to measure pressure, it has integrated temperature compensation. But for really for cooling in space and also for our device, we are using just radiators because infrared radiation we have if it more warmer than environment, the radiator just by radiation without air can cooling electronic devices. And if you will see in detail International Space Station, there are a lot of panels, but most of them it's not solar panels, it's heating radiators to cooling a lot of laptops inside the International Space Station.
Thank you. And we have another question from Ivan. How many people do you have in your team, if you can disclose this?
We don't have constant team. It's not a business, it is not a company, it's like a team of enthusiasts. So in some launch we have 5 people, and some people helped us to prepare a mission, but I think in average about 10 people involved in one mission.
Great. So we have a few comments, not the questions, but comments. Great presentation, thanks. Great topic, all best to your journey. So thank you for this great presentation, Dmytro. And we have another question. Is it difficult to join SoftServe team if I'm web UI developer? Any requirements or steps to do? yeah, so of course it's possible for all people who have corresponding skills to join robotics group, and a small spoiler: we are working to make it easier for majority of people to join robotics field. There will be a pass to follow, and at the end of the pass, yeah, you will be almost there. I don't want to disclose more, so watch our follow us on social media. Everything will be there, but it will take like months or two, and yeah, you will have more info on this question. Dmytro, one more question to you. So it's again a comment. One more proof that two pizza teams can achieve astonishing result on not too low budget.
Yeah, it's exactly what I want to show in my presentation. That it is possible if you want really on this.
And another question from Andrei. Did you take ionization radiation into account? High energy particles can produce short circuits or damage data in RAMF flash, as I know.
Yes, it's a very important problem for outer space, but in low orbit and like in atmosphere, it's not very critical. It's possible. So for these purposes, we use just usually we launch 2 cameras, 2 trackers to avoid to lose something. It is exist, but in orbit. And during Mars and Moon mission, there are a lot of special developed devices is used for these purposes. We have one company in Germany with Ukrainian founder, which produce this special electronic devices, special chips. One chip cost about 6. For example, for power conversion from 5 to 3 volts, cost about $6,000. So yes, it is problem, and therefore space solutions like cost a lot, but you can have some workaround to use a few microcontrollers or 5 data storage to compensate if something will be broken by this high radiation.
Great, thank you. And so the time of our event is over. I'd like to thank our speakers for their great presentation and answering all the questions. I want to say kudos to winners of our Kahoot challenge. So you will receive all the prizes. Thank you for providing your emails. And one small announcement from my side: after the event, you will receive an email with feedback form. So I would like to kindly ask you to fill in this feedback form in order for us to get better the next time when we will have a similar event. So when it will be, I will not tell you. Follow us on social media and you will know everything. And thank you for your time. Thank you for attending this event. And yeah, see you next time. Goodbye.
Bye.